So why don't we go ahead and jump right into the content here. So today we're going to be talking about 3 different things. The first thing that we're going to talk about is, why isn't AI more pervasive? Why isn't it being adopted more? What are the challenges? Why are there challenges around this particular topic? The next thing we want to do is look at an example of explainable AI in action. What does it look like? What are the different content areas that are exposed to gain trust in the user base that is expected to adopt a particular model or algorithm? And lastly, we'll be talking about what's next. What can organizations do to further their AI ambitions? So without further ado, let's get into the content here. First of all, 95% of executives cite cultural, organizational, and process challenges in AI adoption. 95%. That is a huge number. It's staggering. It's astronomical. Almost all organizations in the US are citing these challenges. And at the heart of these challenges is trust. Humans inherently have trust issues with machines telling them what the answer is. When somebody says they have a gut feeling about the right answer, and it's different than what the machine is telling them, they will likely lean towards their gut feeling here. So this really has to be addressed in some manner in order to unlock the full potential of artificial intelligence. So AI is branded as a black box. This black box decision-making machine, there are things that get thrown in there, and again, if people don't trust them, people won't trust the answer if they don't understand what is going into the decision, right? So not only the decisions themselves have to be explained, but what went into them. We talk a lot about people being held accountable for these decisions in industry. And it's really important to understand for executives, who are usually the ones accountable for this, to be able to understand what's going in them. So we really have, a huge need here in establishing trust and getting that black box to become more transparent, if not fully transparent. All right, so if the black box is really what AI is at this point, we need to shed that black box brand. And that's rooted in trust. And I really like this quote here by John Mertz, that trust is active through believing. Trust is maintained when our confidence in something is consistently realized. Well, that means that someone's character, they demonstrated that they can be reliable, that they are trustworthy, that they'll do what they say, they do the right things morally and ethically, and they gain trust, right? But how does a machine demonstrate character, right? Those are all of the things that go into a human's character. But how do you get a machine to demonstrate that they are making the right decisions, that the inputs are the right inputs to use at the given time, that the variables that go into the features are the right ones and in the right sequence? So there's a lot of different things here that we need to demonstrate in order to gain trust in what the AI outputs really are. So let's move into what explainability is. And the ability to understand and interpret the inputs and outputs is at the heart here. And there's really 3 things that go into making algorithms and models understandable, or explainable. The first of which is transparency. Transparency is the process that extracts parameters from training data and generates labels about what those features, what the feature outputs have come up with, right? So we can actually see what went on and what the resulting output was. Interpretability is the piece where anybody can understand it, right? Explainability has typically been in the domain of data scientists and engineers historically. So interpretability goes beyond that. It goes to business users. It goes to business stakeholders, people that are expected to use it. They need to be able to interpret what the model is doing and what that answer is in order to gain that trust there. And last is explainability. And this is really where it's the definition is more open to interpretation here, but explainability is the collectiveness of the features that went into the model to produce that decision. So these three things come together to create explainable AI. So why don't we look at what's next, right? So we have explainability, but we don't yet have understandability. That's key here. It's the new explainable. And again, I mentioned earlier those business stakeholders, those business users that are expected to use these algorithms, these outputs of these algorithms. And it's really, really important that those who are expected to use it can have that that they can understand, and it's not difficult. They're not extracting and looking at through code to figure out what is going on here. So this understandability is really more around the UI or the UX, the experience there. So understandability has four major pieces of content that go to it. The first one there is that human-centered user experience. And that's where we bring in product managers, people who are CX experts to help design that user experience that a business user will adopt, something that's easy to use, easy to understand, easy to interpret, and is relatively adopted with ease because of that usability there. The second piece is ethical guardrails. And ethical guardrails is not just a thing that happens within a particular organization or business unit that is looking at these algorithms, but it's more broad than that, right? So the ethical guardrails speak to principles that are put in place to guide the use of AI across industries, right? And the way to really codify those ethical guardrails is to actually get regulations put into place, laws put into place. Right now, GDPR says that any user has a right to explanation if they are materially affected by a machine that made a decision for them. So what does that mean? That means that if I get denied for a loan, I am expected to get an answer back from the particular bank who denied me that loan, showing me and demonstrating to me what were the inputs and how the machine got to that particular output. The third piece here is design thinking. And design thinking is really value-driven requirements. and where explanations for decisions are expected. This is embedding that that user experience where it needs to be when the decision is happening in that moment. So it might be embedded in a particular application. It might be embedded in a mobile app that gives you a notification about a particular decision that needs to be made or needs to be evaluated. Those are the types of things that we incorporate when we talk about design thinking. And lastly here, we want to talk about accountability standards, right? I talked a little bit earlier about a person or a group of persons being in charge of these algorithms. And most often in organizations, it's usually at the C-suite level. And because you can't send a machine to jail, you have to have somebody responsible for it. So the accountability standards really talk about accountability and bias, cybersecurity, making sure privacy laws are being followed, monitored, and acting to that standard, not just or even going above and beyond that standard, right? To make sure that there's no biases and no issues with things such as privacy. Now, having said all of those things in terms of explainability and understandability, I want to move into XAI in action, right? So what are some examples of XAI? How do you know you're choosing the right model or the right method or framework to follow in terms of using or creating the explainability around the model? So these are some examples of methods that are being used for explainability. Now, these 4 particular examples are not all inclusive. They are not the whole realm of methods that are out there, but I just wanted to give a little bit of, shed some light on some particular examples. So the first one that we will talk about is the SHAP methodology. And the SHAP model, for each feature input, you have a prediction of almost any algorithm. So this method can look at any set of algorithms, any set of models, and be able to come up with the features, the variables that went into it, and give an explanation for how it was made. Now, so it's rooted in the contribution of the feature to the final prediction. So we're going to be talking about an example here later using the SHAP model. But right now, let's have a look at anchors. And anchors are high precision if-then rules. So these are sets of business rules that are created and taught to the machine, the algorithm, and they follow it precisely every single time. So you know exactly what's being inputted, you know exactly what variables are going into it, what features are going into it, because it's all based, the code is based in that business logic. The next method we'll talk about is the SUM method, contrastive explanations method. And this one evaluates which features should be minimally and sufficiently present for that prediction to be produced. And on the other side of the coin for contrastive explanations is that it also looks at which features should be minimally and necessarily absent. So this starts to look at, ignoring certain things that shouldn't be going into into the particular models. It could be demographic information, perhaps is an explanation there of the contrastive explanations method. And lastly, we have counterfactuals, right? And counterfactuals describes the smallest possible change that can be applied to the features that you can know exactly what the outcome will be. So that's an interesting one to be able to play with different variables and know which will affect the outcome and really get you the outcome that you're really looking for. So again, these are certainly not all inclusive, but this is a lay of the land, if you will, for different methods that are available out there for explainability. All right, so let's have a look at SHAP in action. So we're going to be looking at predicting survival on the Titanic. So in this particular example, we use the Kaggle Titanic data set to show SHAP in action. We are going to look at this and walk through it using something called Explainer Dashboard. All right, so this first area gives an overview of all of the different things that you can look into. So if we look at the tabs, the very top, we have such things as feature importance, classification stats, individual predictions, what if, feature dependence, feature interactions, and decision trees. So as we're looking into, again, this example of predicting survival on the Titanic, if we look at feature importances, by far and away, sex was had the biggest impact on survival rate. The ones that followed, deck and passenger class were about even, but again, by far and away, sex was the primary indicator on whether a person who was on the Titanic survived. So again, we can look at all of these different feature inputs that went into the algorithm which predicted survival. I think it's a really interesting one. If we look at number 8, the number of the siblings plus spouses on board. This one caught my eye originally because I thought to myself, how could that possibly have an effect on survivor, whether you were a survivor or not? So I did some more investigating, and it turns out that if you were married and had more siblings with their spouses, you were likely all together, which increased your percentage of survival in terms of the Titanic there. So why don't we go ahead and look at some other functionality within Explainer Dashboard. All right, so now we're going to look at an individual prediction. And this one happens to be for Harry Homer, okay? And the likelihood that he did not survive was almost 80%. Only 20%, that he survived. And the reality of it is he did not survive the sinking of the Titanic back then. But how do we know that we had the confidence of 80% probability for Mr. Harry Homer? Well, why don't we double click into that a little more? And let's look at something called the contributions plot. And this is how each feature contributed to the particular prediction. So this prediction here shows a number of different attributes, if you will, for looking at the probability of survival. And if we look at the ones in red there, those are indicative of not survival. So sex, deck, age, number of parents plus children on board, those were the things that predicted the survival in a negative way for this particular person. Again, Mr. Harry Homer. The items in green on the other side actually went into his favor, and those were passenger class, when the passenger embarked, what their fare type was. And again, back to that example I was talking about before, the number of siblings plus spouses on board actually proved to be a positive input in terms of predicting survival during the sinking of the Titanic here. Let's look at one more item here. And this is the partial dependence plot. And the partial dependence plot looks at how the prediction changes if you change one feature. So in the application explainer dashboard, you can drop down the drop-down list on the feature there and change it from sex to where they embarked, or what their class of ticket was, what excuse me, what the particular fare of that ticket was, to see what the inputs were on this particular example. And again, you can toggle through all of the different passengers to see how the different features played into their individual survival rate. So there are things that the SHAP model really brings into play here. So, these are, charts and graphs that are, semi-usable. I was a developer once upon a time, and I can get these, they're pretty user-friendly. But someone who's a more business stakeholder at their core might still struggle with interpreting some of these particular graphs and charts, right? So how do we change this? How do we make this more usable? How do we get the business population to buy into these particular algorithms? So what is next, right? We talked earlier again about that explainability and understandability and what the differences are. And the key is machines will never take over outright, but the key here is understandability. So when we think of these models and we think of the outputs, and we're looking at explainer dashboard and these different techniques that can be used to fully unlock AI's potential, we really want to make sure that we have that strong user experience. One of the big things here is bringing together data scientists, data engineers, and CX designers, product managers to design the explainability interface. Again, getting users, stakeholders, the answers they need in the moment in which they need the decision. So whether that's in a notification on a mobile supply chain device, or whether that's in a particular application, it really just depends. But understandable AI is the key to it. So that's where we're headed, and we need to be collaborative in terms of coming up with that interface in order to get the stakeholders on board and garner the trust that we have been looking for in order to get users to adopt here. And with that, I thank everyone for attending today. I appreciate your time, and I'm available for any questions or follow-up.